Let me define this is theta, and let me define this is y. Some contrast color. Yeah, y. This is x. Let this be theta. This is r. Let this be equal to dx. First, we'll calculate the viscous force acting on that element. Viscous force acting on that element. Then and we have eta equal to alpha into mod x. So it is moved with a constant velocity. Then what is the horizontal force that should be applied by the external agent? Usually we do get problems of this kind, no? When you apply force. So if you know this L in B, so what is the viscous drag that is acting? That should be equal to eta here area LB V by thickness of this viscous layer. Something they'll put T, that T you're going to put it. You have well-defined structure here. What is the area of contact between the body and the viscous layer? Will be called LB. So it's very easy. But look at here now. And that too, the quotient of viscosity is varying. The quotient of viscosity will be different at different points. This is x equals 0. So therefore, first we'll assume a elemental strip. First we'll calculate what is the force acting on that elemental strip. Then we'll integrate. Hope you are able to understand. If eta were constant, it will be very easy. So what is the area of contact? Pi r square. I would have written pi r square. If this eta were constant, then what is the viscous drag that will be acting is eta into pi r square v by t, where t is the thickness of viscous layer below. But here eta is variable. So therefore I had to take help of some integration. Very good question. So I already discussed in class. I thought, okay, better to revise possibility of asking. It's there, one of the best books. This question is available. Possibility of JEE advanced process may pick up this. First, we'll calculate the force acting on this strip. Force acting on the vertical strip. So dF is equal to eta 2 times of eta 2y dx speed by thickness. T is a thickness that all given. You read the question. There is some liquid is there below the disc whose thickness is T, that one. Okay, let's get into, I think from here the mathematics will begin. Your physics is over. From here the math is what you have to take help of this one. So I look at the triangle x square plus y square equal to r square. Then I can replace y as r square minus x square. Cos theta equal to x by r. So dx also I should replace dx equal to minus r sine theta d theta. Why I should define d theta? Because here, what is the d theta? D theta will come into picture in this way. If I rotate theta, d theta from 0 to pi by 2, I do get the force acting on the strip due to right off. Twice of that will be the total viscous force. Hope everyone, you are in better position, integration all. Let me substitute all these things. So df is equal to eta r square minus x square. Y value is substituted, dx will be minus r sine theta d theta v by t. What is x? X equal to further r cos theta.
R sine.
This negative sign, let it be outside here. So r sine theta vt. R will come outside, 1 minus cos square theta sine square theta. This will, everything will be sine theta. R square sin theta cos theta Vt.
Sin square.
Sin square, sorry. Dx d theta, I'm missing d theta. Now what is eta? We'll bring the eta now. Alpha x r square Vt sin square theta d theta. X we can write r cos theta.
Also into 2.
Okay, two is missing here, no? Minus 2r by value is substituted. Okay, yeah, 2 will be there. 2 minus 2. Yeah. Now x equal to r cos theta. df equal to minus 2 alpha r square v by t. Let it be everything outside. X equal to, this is again r cos theta sin square theta d theta minus 2 alpha r cube v by t cos theta sin square theta d theta. This will integrate from 0 to pi by 2. We'll get the force acting on the right off of that one. 2 times of that will be total force acting on it. Force.
Minus pi by 2 to pi by 2. No,
or we can change the limit. No, here not minus pi by 2. Already I defined twice, no, here 0 to pi by 2 only. I'll get force acting on the right off. I took 2, no, here y and y. Hope.
Yes.
So 0 to pi by 2, the force acting on one off, I'll write it. Total force will be twice of this. Anybody just integrate and give me the value. There's everything, simplification of this.
4 alpha.
Final answer or f of?
Final, sir.
Final answer.
F net.
4 alpha.
R cube V by 3t. In the denominator, it should be 3t, sir.
3t. There's no option, no? So I'll make change. Sai Krishna, nothing is there, just mathematics. Integration, what to explain?
No, sir. Upper parts first.
No, after first equation, all mathematics, no. Look at the triangle, everything.
Starting, sir. Starting.
Starting, there is a force, no. Viscous force formula, eta 2 pi r. That this 2y by dx, 2y dx, area of the strip, pink color strip. Okay. Formula, F equal to eta a dv by dx. So what is the area of the pink color strip? 2y dx.
Yes.
Then the second question, why not area of elemental strip 2 pi r dr? This elemental strip is, it's like a rectangular strip, no? And if you assume this is circular strip, not possible, you can't define, because eta is a function of x, no, very difficult to define. If you assume in this circular
First option is not correct.
I made it 4 by 3, huh?
But pi is not there, no, sir, here.
Pi is not there. Even
And it's r square.
R square. Okay, I'll change everything. 4 alpha r cube v by 3t. Okay. Now, why can't you assume a circular strip something? So here, if you assume a circular strip, what is the problem? The eta is different at different points, no? And you can't define elemental strip. What do you mean by elemental strip? The value of eta should be same. Okay, are you getting? We should not assume circular strip here because of eta variable. Huh? Above question not circular, it's a cylindrical one.
Sir, here also we can't take 2 pi r into dr as area.
You should not do no elemental integration. How you can integrate? How you define that elemental strip? The force on all parts should be same, no? If you take the circular strip, the force acting on the strip will be different at different points. On the elemental strip, it will be different at different points. Then how you define that elemental strip, no? The force acting on this element and this element will be different. So we can't do any mathematics there. Okay. Just simple, you have to then rate of generation of heat. So rate of generation of heat means power. So 4 alpha r cube v square by 3t. Pi should not have been there. Okay, no. So these are the some simple idea. This one, I think of all this is very important, I feel. Assuming that rectangular strip is something very important. Once after that, everything is mathematics you can manage. So just do primarily focus on these aspects. There's a very good lengthy question. I want students to really think on this. Okay.